Theorem. This is the theorem. Let f be a function defined so these are the things, remember how we talked about intermediate value theorem, where it had like a defined set of things, like for example, you had to find the highest y value, you have to find the lowest y value, you have to state that the graph was continuous, and then there would be a y value that falls between those y values. That was intermediate value theorem. Mean value theorem, same restrictions, with a little bit of an add-on. So let f be a function defined on the closed interval a, b, if f is continuous on a, b, so we have to have continuity again for this theorem as well. And f is differentiable. So if it had like a cusp in it, you wouldn't be able to do mean value theorem. Or a corner. And the reason why we have rounded brackets is if you actually went to those endpoints and found the derivative of them, they'd be horizontal tangents, right? So, or they could be vertical. So we only do the rounded part. Then there is at least one number C, I don't know why those use C's, they do, in the open interval AB, now this sounds way more intense for which, but it'll actually make a lot of sense in a second, for which f prime of C equals f of B minus f of A all over B minus A. Bless you. Like I said, it sounds way more intense than it is. So let f be a function on the closed interval AB. F has to be continuous. F has to be differentiable. Then there is at least one number C, so one x value, in the open interval AB for which the tangent slope equals the slope of the coordinates. This here is tangent slope. Where the tangent slope equals the, what's this? Grade 10 slope. So, I'm going to show you a graph of what this means. So if I gave you a graph that looks like this, and this is my closed interval endpoints, correct? The right-hand side of this is grade 10 slope, correct? The right-hand side of that equation is grade 10 slope. So basically, if I found the grade 10 slope between here and here, yeah, I should give myself a high five. That's actually kind of good. Thank you. Thank you. I'll be here all week. Thanks. I feel like I need the clapping like Minecraft. They have way more clapping than I get in class. I feel Minecraft makes way more money and gets way more clapping. I don't get clapping points. Oh wait. So do you see how that's the grade 10 slope, guys? That's the grade 10 slope. They're saying the tangent slope somewhere on this graph will be the same. You have to give me that x value. So if I ran like that, maybe it's here. Pretend I actually drew that on the graph. Maybe it's here. This one would probably have two that are running at the same tangent slope. Okay? They want the x value that correlates to that. That's it. So this graph probably has two spots where the actual x values, there's tangent slopes that run at the same as the slope between the a and the b. That's all we're doing. So mean value theorem states that if the graph has your normal grade 10 slope between a and b, wherever these endpoints may be, we're trying to find the x values where on the graph there's tangent slopes that run at the exact same slope. So basically, you find your tangent slope at a value c, and you set it equal to the grade 10 slope, and then find out what c is. That's it. So let's look at example 1 so that you understand it's actually not that hard. The catch, though, is if you're using mean value theorem, you have to state that the equation, you can find the derivative of it, it's differentiable between those values, and it's continuous between those values. You have to have those statements, just like you have to say it's continuous for intermediate value theorem. All right. So, oh, woodpeckers, I love them. Find the number c that guarantee the intermediate value theorem. I didn't mean to write intermediate. My brain went back to last unit. Mean value theorem. Sorry. Given f of x equals x cubed minus 3x plus 5. Negative 1 is less than or equal to x is less than or equal to 1. So in order to do the mean value theorem, we need to know that f prime of x equals, I guess we should say f prime of c, equals f of b minus f of a over b minus a. So first off, we need to get the first derivative with respect to c, right? So let's find that over here. So f prime of x is what I'm going to find first. So what's the derivative of f? 3x squared minus 3. But I want f prime of c. So that just means 3c squared minus 3. We agree? So the left-hand side of my mean value theorem is 3c squared minus 3 equals. Now I have to find the right-hand side. The right-hand side is grade 10 slope. We agree? Between negative 1 and 1. So I need to find f of negative 1, which is negative 1 cubed minus 3 times negative 1 plus 5. So f of negative 1 equals negative 1 plus 3 plus 5, which equals 7. So f of negative 1 equals 7. It's my one coordinate. And I have to find f of 1 equals 1 cubed minus 3 times 1 plus 5. So f of 1 equals 1 minus 3 plus 5, which equals 3. I just literally got coordinates, correct? So we're going back to grade 10. we have a coordinate -1, 7, which we can label x1, y1, and then 1, 3, which we can label x2, y2, and then we're literally doing grade 10 slope. Could you do FB, FA, label them A's and B's? Sure. Or could you just do grade 10 slope over here and not try and hurt your brain? I would just do grade 10 slope. So I'm going to do y2, which is 3, minus y1, which is 7, over x2, which is 1, minus x1, which is -1. So I get 3c squared minus 3 equals 4 over 2. So 3c squared minus 3 equals 2. Yeah, negative. Now we have to solve for c. Now because it's a quadratic, we could move everything to one side and use quadratic formula. Or whenever there isn't a c, like there's a c squared but there isn't a c and then there's a number, I can just solve for it by moving everything to the one side, right? So I can add the 3 over, and I get 3c squared equals 1, divide by 3, and I get c squared equals 1/3, and then I take the square root. What do I have to remember when I do this with my hand? Plus minus. So I get c equals plus or minus 1 over root 3. Welcome to calculus. You don't have to rationalize. So those c values are on this graph, this cubic function. This is a cubic function that is at x cubed minus 3x plus 5. If I drew that and I found the slope between -1 and 1, the place where the tangent slopes will occur at that exact same -2 slopes are when x is -1 over root 3 and when x is positive 1 over root 3. Do you get what I'm saying? So is the c values. Okay, I'm going to get you guys to try another one. You get 10 minutes. Optimization. So these ones, the related rate questions will give you like volume, area, all those things. And then they just ask you for like the change in rate of the height or the change in rate of the radius or the change in rate of those things. So those are the derivatives. Optimization questions ask you for like max area or maximum volume or minimum volume. One of the biggest questions that comes up is like the one in grade, you guys did it in grade 11, and it's like a farmer question where they ask you to like find a max area if this farmer fences in this. Oh, I hate it. Yeah, welcome. It's here again. But it's way easier because that one you had to actually complete the square so that you could get it into vertex form, and you would use the back number. Now we get to use derivatives. Okay. So, example 1. A farmer with 4,000 meters of fencing wants to enclose a rectangular plot. Okay, that borders the straight river. If the farmer does not fence the side along the river, It's a gift. What is the largest rectangular area? That could be enclosed. So, they gave me a farmer with 4,000 meters of fencing. Now, some people say, well, that's the area. Are you fencing the entire area? You have cows that are like stuck like this in fence. That's not how fence works. Okay, we don't fence the whole area. We fence the what? The perimeter. So, we know that we have, I better just box that in blue. We have a lovely little rectangular area. Pretend that those are straight. If you want the maximum area, keep in mind, if you use widths and lengths, that the widths will be the side ones and the length will be the longest one, because you're going to try and use the longest one to not have to fence, because that'll make you the biggest area, right? If you use this here to not have to fence, you're going to get the largest area. If that confuses you, you can always just go X, X, and Y. Like, you don't have to label them as lengths and widths. But the perimeter of this one is X plus Y, right? Because we don't need that other piece. You agree? So the perimeter is X plus Y. Or we could say the perimeter is 2X plus Y. And we know the perimeter. What is the perimeter? Pardon? 4,000. That's the amount of fence that I have, correct? So that's the amount of fence I have to go around the perimeter. So the perimeter is 4,000. And we're trying to find the largest area, aka max area, correct? So area itself would equal X times Y. Do you agree? If we want the maximum area, we're going to need the first derivative. The first derivative with X's and Y's is super complicated. So what could I do so that I only have one variable? Thing you learned in grade 10, what? Yeah, move this 2x over and isolate this for y. So we get y equals negative 2x plus 4,000. And then substitute that in for the y. So we have area equals negative 2x squared plus 4,000x. And then last year you had to complete the square in grade 11 so that you could get into vertex form. Your x value was whatever the variable would be, and then your maximum was the y of the vertex. Now we want max area. If we want the maximum, what do? We get the critical numbers of the first derivative, correct? So I need to actually just find the derivative of that. So max area equals negative 4x squared, that's a lie, negative 4x plus 4,000. And then to get the critical numbers, I just set the first derivative equal to what? 0. So I get 0 equals negative 4x plus 4,000. I can either add the 4x over or subtract the 4,000 over. Divide by 4. X equals 1,000. So x is 1,000. Meters. How the heck do I get y? You put it back in here, right? Negative 2 times 1,000 plus 4,000 equals 2,000. So if they ask me for the dimensions would be 1,000 by 2,000. Brain stopped. But this is what is the largest rectangular area. So how do we get area? Yeah. So it equals 1,000 meters times 2,000 meters. So area equals 6, because you have 3 and 3. When you multiply, you just keep the zeros. Keep the arrows is what I was going to say, but I don't even know where the heck that came from. So the max area is 2 million meters squared. Example 2. This one was like the volume question in polynomials in grade 12, math 30-1. From each corner of a square piece of sheet metal, from each corner of a square piece of sheet metal, centimeters on a side. Remove a small square. And turn at the edges to form an open box. What are the dimensions of the box with the largest volume? So when we did this in 30-1, they gave you an image. It was on an old phone where they released the questions, so I shared it with you. And it was like 20 by 10 or something like that. And it was a rectangle, correct? This one is a square. That is not a square. So that's not that great a square. Pretend that's a square. I do. I need an exact amount of squares. Okay. So remember they did this to it? And then I took a scissor and cut it out in class, but we could cut these pieces off, technically. Because this is a square that doesn't look like a square because I suck at drawing. First step is denial. Second, I went right to acceptance. My drawing skills, subpar. But anyways, we labeled these as X's. Remember that? Those were X pieces. So the whole length across is how much? 18. But we have to take off what? Minus 2x, right? And then this length is pretending to be the exact same, but drawn really crappy because that is for sure longer than that. This one would be not, the image is not drawn to scale. That's what I would have to put on my image because it sucks. 18 minus 2x. And I want max volume, right? So I want volume. The plain old volume formula is length times width times height. So mine would be 18 minus 2x times 18 minus 2x times what? x, which I could rewrite as 18 minus 2x squared times x. If I want max volume, what do I want? The derivative, correct? Critical numbers is the first derivative, maximum, minimum, those screen critical numbers is the first derivative. So I need to find the first derivative. So what could I do? I could expand this and then do power rule, or I could do product rule technically, then expand it after. It doesn't really matter which route you go. So this would be G times F prime is a chain rule. So I get 2 times 18 minus 2x to the 1 times negative 2. So I have to drop the 2 in front, rewrite it to the 1, and the derivative of the inside. Plus F, which is 18 minus 2x squared times 1. I can take a GCF out of it if I wanted to, and 18 minus 2x. And then I'm left with negative 4x plus 1. Oh, plus 18 minus 2x, actually. So I get 18 minus 2x times negative 6x plus 18. So I have to set them equal to 0 to get the critical numbers. 2x equals 18, x equals 9, and then negative 6x, don't know what I'm doing, plus 18. Now you have to watch yourself just like you did in 30. If I use 9, what is the length of this and the width of this? I use 9. 0. Can I have 0? No. So this would be extraneous. If I use 3, I would get 18 minus 2 times 3, which is 12. So my dimensions would be 12 centimeters by 12 centimeters by 3 centimeters. Right? And if they wanted max volume, I'd have to go 12 times 12 times 3. They don't. They want the dimensions of the max.